All right, here's the last section of Chapter 8 that we're going to be doing. It's the double and the half angle formulas. And there's a whole bunch of them. I'm only going to go through the proof of one of them. And then if you look in the book in section 8.6, it shows you how the other ones are proven. The reason why I'm proving this one is because it's the one that I see the most in calculus. And that is the sine of 2 theta. So you get it, it's doubled, the angle is doubled, is equal to. So it would be an addition formula, right? So we get sine of theta plus theta. That would be the same thing as doubling. How do we do that? Well, it's the sine, cosine, cosine, sine the thing. So it's sine of theta, cosine of theta, plus cosine theta, sine theta. These turn out to be the same. That's reversed, but the commutative property says that those are the same. So this turns into 2 sine theta cosine theta, and that's what sine of 2 theta is equal to. And that's right here. And I see this one quite a bit in calculus class. This one comes up when we're solving equations. We have to make a substitution, like we have this here, and we substitute this in for it. So if you're solving some kind of equation in calculus and you get this here, and you're like, okay, I don't know what to do. I need to change this to a single angle instead of having the double. So you can swap it out, and maybe some factoring and some things that we've done like that. So there is a relationship in calculus between sine squared. So if you square sine and the 2 sine theta cosine theta, which of course is sine 2 theta. So there's a relationship between these two graphs, and that's one of the things we look at in calculus. So that's kind of why this here is understanding that these are the same. It's kind of an important thing. And I'll try and show you the relationship of those wherever I set my calculator. Here we go. So here's my calculator right here. So I've typed in this and this, and there is a relationship between those, the double angle and then squaring sine. So here it is. The blue one is sine squared, which makes sense because sine squared is never negative. So and it's periodic. It's going to go up and down and up and down. And then the double angle would be there's it's double angle. So it's just it's the sine curve. So there's the mountain and the valley and the mountain and the valley and the mountain and the valley, but it's twice as fast. Remember that 2 makes it be twice as fast, so that's what the graph does. So what happens here is the blue is increasing, and then the red is all the y values are positive. And then the blue is decreasing, and then all the y values are negative. Then the blue is increasing to here, and all the red values, the y values, are positive. And then right here it's not increasing or decreasing, so then it's 0. So this is the relationship between the function and what's called the change of the function, the derivative. So that's one of the things that I see in calculus is those. So there's this one here only has one version of it, where you get all kinds of versions of this. There's all kinds of different versions of doubling the cosine, and that's because it's cosine squared minus sine squared, and then you can swap in sine and cosine for that. So you can substitute in like what is sine squared? Well, sine squared is really 1 minus cosine squared. So you can swap that in here, and then you'd end up with this one, all cosines. Then you could swap in here 1 minus sine squared, and you get this one. So that's why you can do 3 different versions of it, because essentially there's one version of it, and you can make those adjustments depending upon what you need to do. So that's the double angle formulas. Of course, there's a double angle formula for tangent. So there it is right there. Now, if you rearrange these, so like for example, you can solve for sine squared here, or you can solve for cosine squared, you can solve for tangent squared. So then you get these alternate things. So if we solve for sine squared, we could get this one. Solving for cosine squared, we could get this one. Solving for tangent squared, we can get that one. So those are just, if you need to swap out another version of what tangent squared is, you can get that. And these are all in the book. The other thing in this section is called double and half angle formulas. So the other thing in there is cutting all the angles in half. So here's a version of cutting all the angles in half, but they're all squared. So then you could take the square root of all those. So you get formula 9 here, and then formula 10, 11, and 12 would be taking the square root of all those. Plus or minus sign is determined by the quadrant, so you have to pay attention to that. And let's see, so there's sine, cosine, tangent, and then there's a couple other versions of the tangent that you can also use. So this starts to get a little bit crazy, doesn't it? All right, so we're going to do some problems out of here together on the 9 through 20, and we're going to do some problems out of the 21 through 30 together. So we're just going to do these problems together, and then I have a take-home test for you to do. All right, let's start with the pencil one, the exemplary problem. That's number 9. So here we go. All right, we're doing this in real time. Here we go. We're given the angle. We know the picture of the angle right here. We know what quadrant it's in. So it's in the first quadrant, and that's the ratio. So if you know that, you know the picture, don't you? So what is sine? Sine is what over what? Y over R. So I know the y value is 3, and then 5, and of course it's just a 3, 4, 5 triangle. So now we know the sine of theta, the cosine of theta, all that stuff. So the first one here is sine. So we got sine 2 theta, which would be 2 sine theta cosine theta. So that's the first thing I'm supposed to know about, is what is the sine of double the angle. So here we go. 2 sine of the angle, of course, is the 3 fifths, and then cosine of the angle would be the 4 fifths, right? So we just got to multiply this together. So that would be 24 over 25. All right, so then B would be cosine of 2 theta. So we got 3 choices on that one, right? Which one should we use? This is the one that I kind of remember the most. So I'm just going to use cosine squared minus sine squared. All right, so then we get cosine. Cosine of theta was the 4 fifths. We got to square that. And we got a 3 fifths, right? And we got to square that. So we get 9. No, that's 16 minus 9. So it's 16 25ths minus 9 25ths. So 7 25ths. All right. So we got this one and this one. Now we're going to do half angle. To be honest with you, the half angle ones are ones that I don't use a lot in calculus. So I'm not as familiar with those. We got the half angles here. The double ones I feel like are more important. Let's see, which half angle should we use here? I'm looking at the paper myself. All right, right, well, we're in the first quadrant. So that's what they're talking about with the, determine the sign based on the quadrant. Well, we're in the first quadrant, so we know that sine, cosine, tangent, everything's positive there. But if we were down in this quadrant here, then we'd have to have the negative version of the sign, right? So we're taking this angle and cutting it in half. It's definitely going to be in the first quadrant. Let's see. So it's going to be square root of 1 minus cosine theta. They use alpha in the book, doesn't matter, over 2. All right, so that's the formula for that one. So it's going to be 1 minus cosine of theta, that was the 4/5, right? And then divided by 2, and take the square root. That should be it. So that would be 1/5 divided by 2. One-fifth divided by 2, which would be 1/10. So it should be the square root of 1/10. Because that would be 1/5 divided by 2. Yep, square root of 1/10. Okay, now we got the half angle for cosine. D, cosine of theta. Divided by 2. All right, so it's going to be the plus version of this. So it's going to be square root 1 plus cosine theta over 2. So there's definitely a pattern to these. If you spend enough time working with them, you would be able to like go, ooh, yay! I get it. So here we are with this. Make sure I'm doing this correct. All right, so then we got 1. So it'd be a square root, it'd be 1 plus the 4/5 divided by 2. So then that would be what, 9, that's 5/5, 9/5 divided by 2. So that'd be 9/10. So it'd be a square root of 9/10. And then of course you could rationalize the denominator and all that business. So what would this be? 9, you can take the square root of, so it would be 3 over the square root of 10. You could rationalize the denominator, make it 3 radical 10 over 10. Same thing here, square root of 1 is 1, so it's 1 over radical 10, which would be, rationalize the denominator, it would be the square root of 10 over 10. All right. All right, that was the exemplary problem in that section. That's the little pencil problem. And the little pencil's cute. They're kind of all the same. Let's try 20, and then I'll ask you to do a couple odd ones by your own, and you can check your answers in the back of the book. So here's 20. It's cotangent is equal to 3, and cosine if theta is less than 0. All right, so that means this is negative, right? Negative. So you got to think about what quadrant that is. So all students take calculus. All students take calculus, right? So cosine's positive here and here. So it's not in the first or second quadrant. And tangent's positive here, so it's positive. So it's got to be in this quadrant right here. It's got to be in the third quadrant. So why does it have to be in the third quadrant? Because tangent's positive. We can rewrite this, right? Tangent of theta is 1/3. Because you flip it upside down, the old flip it upside down thing. So the tangent's positive and the cosine's negative. So it's not going to be up here because tangent would be negative. So it has to be in the third quadrant. So let's draw the picture of it. Of course, tangent slope, so it's y over x. So actually they're both going to be negative, aren't they? But that's a positive slope there, right? The positive slope. And y is 1 and 3. Well, that's not very proportioned out, is it? So not very proportioned out at all. Because that should be a lot smaller than that one, but you get the idea. So it's y over x. And then, let's see, that would be square root of 10, because that would be 9, 1 makes 10, square root of 10. All right, so now we're going to do the double angle formula for this. So we're going to do sine of 2 theta. Well, I'm finding a place to write here. So sine of 2 theta is 2 sine theta cosine theta. Of course, these are both negative, right? There we go. So it's going to be 2. The sine would be that over that, negative 1 over the square root of 10. And then the cosine would be negative 3 over the square root of 10. And I guess it makes sense that the answer is positive, right? Does it make sense that the answer is positive? Because if you double the angle here, that's the angle. If you double it, it's going to flip it back up to the first quadrant, wouldn't it? Or into the second quadrant, so it's going to be positive.
Elders in this crisis.
All right, so now we're going to multiply this out. We get negative times a negative is positive, times 2 would be 6 over 10, which is 3/5. So that one's 3/5. B is cosine of 2 theta. I think I'm going to do what I did the last time. I'm going to do cosine squared theta minus sine squared theta. So the cosine is negative 3 over the square root of 10 squared, and sine is negative 1 over the square root of 10 squared. It's already had the answers right there, so there's the cosine 1 squared and the sine 1 squared. So I square that and I get 9/10 minus square that 1/10 to be 8/10, which is 4/5. Oops, ran off the screen there. 4/5. So that's that one right there. Let's see. The next two are really ugly. The bell's ringing for no reason. Okay, go to your next class, guys. C. So we got sine of the angle cut in half. All right. So we cut the angle in half. It's going to be up in here somewhere. So it's going to be positive, right? So it's going to be positive. But if we cut the cosine angle in half, cut this angle in half, it's going to flip it up in here somewhere, right? Because it's more than 180 degrees. So if you cut it in half, it's not going to be less than 90 degrees. It's going to be in this quadrant here. So when we do this one, it's going to be a positive answer. But when we do the cosine one, it's going to be a negative answer, right? Because this is the theta, right there. There's my theta. But when I cut it in half, it's going to put it somewhere in the second quadrant. So sine of that is going to be positive, but the cosine one's going to be negative. Okay, so here's the crazy formula for this. I have to look myself. Here we go. So we decided this one's going to be positive because it's going to flip it up to the second quadrant, and this one's going to be negative because it's going to be in the second quadrant. That's kind of tricky. So here's the formula again. It's 1 minus cosine theta divided by 2 I'll get the positive version of that. So it's going to be 1 minus cosine, which was negative 3. So it's going to be plus 3 over the square root of 10 over 2 square root. All right. Now I'm looking at the answer here, and they've done a lot of rationalizing and things. So just double checking my work here. It is 1 minus cosine divided by 2. So that's the cosine plus. All right, plus. Okay, let me see if I can get their answer. That'll make me feel better. So this, the common denominator here would be the square root of 10 over the square root of 10. So then the answer is going to be square root 3 plus radical 10 over the square root of 10 divided by 2. And that's going to flip up and multiply, so the 2 is going to go there. Then we're going to rationalize the denominator. Rationalizing the denominator, so we're going to multiply by square root of 10 on the top and the bottom. So there's rationalizing the denominator part. So it's going to be 3 square root of 10 plus 10 over 10. That's going to be 10, 20 square root. All right. Hey. All right. If you didn't make the bell, you're tardy. Okay, that's good. And then what they did is they took out the square root of 4 out of this. So they thought about this as 4 times 5. So you can take the square root of 4. So the book's final answer is 1/2 square root 3 square root of 10 plus 10 over 5. So there's a lot of algebra stuff in that. The basic answer is right here. It was 1 plus this divided by 2, and then just all the fractiony stuff after that. But you know, we are in desperate times. My concern is if you try some problems on your own and look it up in the back of the book, you're going to think you have the wrong answer. So type it in the calculator to see if your decimal equivalents to it. D, the sine, or not sine, cosine of the half angle. So we know if we do the half of the angle, it's going to put it in the second quadrant, so it's going to be negative. So we need the negative version of it, so it's negative square root of 1 plus cosine theta over 2. So it's going to be negative square root 1 plus the cosine is the negative one right there, right? So it's negative 3 over the square root of 10 divided by 2. And then the same process happens here. We're going to rationalize the denominator and all that business. Common denominator be the square root of 10 over square root of 10. And if you do rationalize this and simplify it all out, you should get negative 1/2 square root 10 minus 3 square root of 10 over 5. So that's the book answer, and that would be the answer where you didn't do all the rationalizing and the changing of the fractions. And those should be equivalent to each other with the decimals. If you type each one of those into the calculator, they should be the same. Okay, I need a little bit of water before I go on to the next section. Okay, why don't you try number 13, and then check the answer in the back of the book and see if you're right. And then let's do, so we got 9, 13, how about 17? Because we kind of did that one, so you probably could figure that one out. And 17. Let me get you set up with these, and then that'll get you started. So this one isn't too bad, 13. So you got to make the angle first. So it's cosine of theta is equal to negative square root of 6 over 3. And it tells us I'm in the second quadrant, right? So this is my x over my r, right? So the x direction is this way, and the r direction is this way. So we got, there's my theta. So it's going to be negative square root of 6 and 3. And now we need to do the Pythagorean theorem. So wouldn't this be the square root? That's the square root of 3 as well, isn't it? Because that squared would be 3, that squared would be 6. 3 and 6 make 9, and then that squared would be 9. All right, so there's your angle, and it's in the second quadrant because it tells me it's in the second quadrant. Now number 17, cotangent of theta is equal to negative 2, and secant of theta is less than 0. So that means tangent of theta is equal to negative 1/2 because it's flipped upside down. And then secant, which also means cosine, would be negative. Cosine of theta. All right, so all students take calculus. All students take calculus. All students take calculus. What are we doing here? Tangent's negative, so it's here, here. And cosecant's negative, which means cosine's negative, so it has to be right here. So it's in the second quadrant. So the y value is going to be actually positive, right? And then the x value is negative. So the 1 squared would be 5 square root of 5. All right, so there's my theta here. So if we double the angle, it's going to end up over here in this quadrant, right? So you have to watch out for sine would be negative, cosine would be positive. Does that match? 17. 17. Yeah, sine would be negative, cosine would be positive. And then when you cut the angle in half, it flips it back here, so both of them would be positive. The half angles would be positive because they'd be right there. All right, so basically we're doing 4 problems out of here, 2 together and 2 on your own. We did 9 and 20, so try 13 and 17. Check your answers in the back of the book. I got you set up to begin those. Okay, so then the next section is here where you're actually doing what we did the other day. You're actually finding the problems, finding the answers to these, the exact answers. So we're going to do we're going to do the exemplary problem together. 21. It's the pencil, and the cute little pencil. So this is screaming half angle because something's been cut in half, obviously. So sine of 22.5 degrees would be sine of how many degrees? 45 cut in half, right? So my theta is 45 degrees. So that's what we're doing there. So we need to know for the half angle formula. The half angle formula, we just need to know the cosine, right? So the cosine right there, so it's that one. So we do, so it'd be positive, we don't have to worry about the negative version of it, so it's going to be 1 minus the cosine of theta, which is 45 degrees, over 2. One minus cosine 45. Yep. 1 minus cosine 45 over 2. So I know that's my theta because I'm cutting the 45 in half. So cosine of 45, so it'll be 1 minus square root of 2 over 2. over 2. So then that would be 2 over 2 square root. So it's going to be 2 minus radical 2 over 2 divided by 2. That's going to flip up and multiply. So it's going to be 2 minus the square root of 2 over 4 with a square root. And the square root of 4 is 2, so I bet you it's 2 minus the square root of 2 square root over 2. I wonder if that's the answer. Hopefully I did it right. 21. 21. Oh, let me flip back here. I'm trying to be careful. I'm doing these the correct way. Don't want to mess up too bad. I'm going slow. Yes, 2 minus square root 2 over 2. Yay! Alright. So I just did that, got the common denominator here. Again, if this answer right here is going to be decimal equivalent to that answer. That's the Bob back of the book answer right there, because it's all rationalized and stuff. So cosine 45 is square root of 2 over 2. I got the common denominator, so I was able to subtract them. This is like over 1, right? So I flipped it up and multiplied it to make it 4. That stays, but I can take the square root of 4, which is 2. Hopefully that makes sense. So that's 21. I need another piece of paper. 21. So 25, I want you to try. And you can do the half angle on that. And the half angle on that would be 330 divided by 2. So if you do cosine of 330 divided by 2, that's kind of what's happening there. Let's see. How many degrees is that? Oops. So if we multiply this by 180 over pi, right? So the pi's are going to cancel. So it's going to be 15 times 180 divided by 8. Alright, so that's something that's been cut in half. So I'm going to multiply that by 2 times by 2 equals 675 degrees. So it's 675 degrees divided by 2. So 27 would be the secant of 675 degrees divided by 2. Alright. And what is secant? Basically, we just need to do the cosine of 675 degrees divided by 2 and then flip the answer upside down. So just do this one here and then flip it upside down and you'll get that answer there. 675, so how many trips around the circle is that? Let's see, if I subtract 360, so it's 315, so you're working off the 315 angle. So you got to do the working off the 315 angle to do that one. 29. So that's what I want you to do. We did 21 together, so do 25, see if you can get the right answer. Do 27, see if you can get the right answer. And do 29, see if you can get the right answer for those. And I'm going to demonstrate 30 right now. And so basically, I'm asking you to do 5 problems here and see how that goes. So I'm going to demonstrate number 30 and see what happens here. So we got cosine of negative 3 pi over 8. All right, so what is that? I think it's easier to convert them into decimals. So it's 3 times 180, whoops, divided by 8. 67.5, because I multiply by 180 over pi. The pi's cancel. All right, so it's negative 67 degrees. So it's cosine of negative 67 degrees. So that would be times 2, 135. So it's negative 135 divided by 2. All right, well, this is, let's see, now we need the formula for this. So this should be a positive answer, because negative 67 would be in the fourth quadrant. So negative 67 would be in the fourth quadrant, and cosine's positive in that quadrant. And don't forget, oh no, we're just doing the cosine. Okay, just doing the cosine. So the answer should be positive. Yes, the answer is positive. Double checked on that. All right. So now the formula for this is square root 1 plus cosine alpha, 1 plus cosine theta over 2. Of course, that's the theta right there, right? Because it's theta over 2, or alpha over 2, it doesn't matter. And the answer is going to be positive because we know it's going to be in the fourth quadrant, and we know the cosine of it. And then we have to flip it upside down. No, we're not flipping this one upside down. This one's regular. It was 27. We're going to flip upside down. My bad. 1 plus cosine over 2. Okay, just double checking. Again, the formula that I'm most familiar with is double angle for sine. It's 2 sine theta cosine theta. I know that one in my sleep. These I have to look at. I mean, because they just don't come up as much in calculus. But this is a trig class, and we're learning our trigonometry. All right, so I have to do cosine of negative 135 is what I have to do to make this work. So that's in the third quadrant. So 135 would be right here. So it's going to be negative 1, and radical 2, because it's 45, 45, 90. And the answer is going to be 1 plus, cosine is negative in this quadrant, right? It'd be negative radical 2 over 2 divided by 2 square root . And then the common denominator here would be 2, so it would be 2 over 2. Then we put this together. So it's 2 minus the square root of 2 over 2 divided by 2. So then that flips up and multiplies, so it's going to be 4 now. Right? Because you flip it up and multiply it. It's all one big square root. Flip it up and multiply it. So that's going to be 4 now. So it's going to be 2 minus radical 2 over 4 square root. Take the square root of 4. So it's 2 minus radical 2 over 2 square root. Yes, that's the answer. Okay. So in summary here, to do 25, 27, 29 to work with the formulas. And then in the other section, what did I ask you to do? Try the 13 and the 17. So it's 5 problems.